All right. Hi, everyone. Take two. My name is Alexis Christoforidis from Wilderness Labs. And I'm here to talk about Meadow OS and the Meadow platform. It is a .NET and NuttX based IoT platform. And real quick about Wilderness Labs, we are a small company of electrical software and embedded firmware engineers and some people who have become engineers just by imagining what we can do with this. We have our mission is secure and scalable IoT, and we have always had sort of a vision to do this through .NET and a very robust kernel and a system based around that core. So about me, we're gonna skip most of that, honestly. But the important part is that I have worked as a .NET runtime engineer at Xamarin and Microsoft. Xamarin being a startup where .NET was brought into small platforms, such as smaller for embedded, not small, but smaller than desktop, which is to say Android and iOS, Apple Watch devices, and even some video game consoles. The Meadow IoT platform is going back from .NET, has some basic principles that we're trying to bring to everyone. And the major one is modern software development. We all know that that's not really a thing in IoT unless you go all the way to Raspberry Pi. And by modern software development, we mean rapid software development, memory and type safe memory development, bounce checking, etc. A modern compiler that works with you, and modern syntax and composability in the type system. Things that we don't always have down when working in C, like most of us, you and I. But we want to not necessarily abstract, but safely wrap that around in a managed and safe, memory safe language, so that applications can be written rapidly and safely, just as they can for other computer platforms. We want seamless internet security and over-the-air updates as part of our platform. And we consider, of course, as basic principles that the IoT platform is reliable and recoverable in the field. If it's going to be the core of a variety of many devices, the OS needs to be reliable, recoverable, does not, from hardware watchdogs to recoverability and crash reporting. And finally, we are aiming to provide fleet management to all the IoT devices, whatever form they may take. Meadow Cloud is the endpoint for the information from heartbeat and health reporting to command and control, sending down commands to the IoT device safely, to data being streamed up from sensor modules, etc. This is a Meadow in hardware. It is an actual device. We've sold thousands of these. They are used by many of our clients who are prototyping or field testing IoT devices based on it. We have the Feather form, classic for prototyping and being able to plug in. The form factor allows you to just sort of plug in on and work with a similar Feather peripherals. We also have the compute module, our smallest form factor for the Meadow. Real basic here. We're not gonna get too much into this, but it's most people here know the STM32F7. About a 200 megahertz ARM thumb 2 CPU, and the Meadow also has a network processor, the ESP32, and I forgot to put the model there, S3, I think. Anyway, 32 megabytes of external RAM in a chip and 64 megabytes of persistent flash for file system, and the app itself. Really quick, we split Meadow OS into a lower half and a higher half, and sort of like it's mostly to understand the platform. But at the lower half, we have the NuttX kernel. We have our bootloader that handles updating the binary, the OS binary itself, as part of the OTA process. And we have one module of ours called HCOM, which provides USB dev connection, provisioning, and debugging. On the other hand, we have the higher half, which is Mono, and which is a .NET runtime. We'll talk about this in a little bit. And also our Wilderness Labs libraries, Meadow.core and Meadow.foundation, that we are going to talk about more in a bit also. And of course, embed TLS, which we'll also kind of briefly talk about, but that's just a standard TLS library for NuttX implementing internet security. So the Meadow OS lower half, again, the bootloader, as we said, is mostly to just start the NuttX kernel or otherwise replace it with a properly staged update and perform rollback, etc. if the update is unsuccessful. And the NuttX kernel is the main kernel for the Meadow OS platform. It's the first thing that boots. It's after the bootloader, and provides all the lower level capabilities for the OS, from, of course, memory allocator and scheduler to TCP/IP and some of our network drivers, and all the STM32 peripherals, of course, and like the RNG, etc. So we are very much have NuttX on our core, but moving on from then on, things get a little bit different from the usual NuttX model, and I'll explain in a bit. Next up is ESP32 comms. The ESP32 chip provides Wi-Fi and Bluetooth for us, as well as I forgot to put this here, but this is where we put our key pair to keep it away from the user app processor. So we use it for encrypted secret storage. But this is a whole component that our firmware engineer Mark Stevens, and Wilderness Labs veteran, has written. I forgot to link it here, but I will link it afterwards because he's already presented on this. We're not going to get also too deep into this, so I basically wanted to link into his fantastic presentation about how he build a bridge between ESP32 and the STM32 for providing a user sockif driver for Wi-Fi. HCOM is the next component, which is USB connection. That's how we put things on the device, how we provision the device, and a few messages such as provision, write file, read file, device info, and how we build a USB channel through which .NET debugging commands flow through, and that's how we have .NET debugging. OS and app updater, what it says in the box, and the rest of this lower half is us pretty much exposing a lot of low-level functionality to user space. Now, going to the higher half, where these things get interesting, we have Mono, which is a .NET app, which is our .NET app runtime. Meadow Core, which provides an I/O API, app lifecycle management, and over there update management. Meadow Foundation, it's a peripheral layer and platform utility code. And finally, Meadow Cloud Daemon provides health reporting and push updates. What is Mono? It's new for a lot of you, but it is an open source .NET runtime, and one that has a long pedigree for portability. It has an interpreted mode anything from an interpreted mode to ahead of time compilation mode in LLVM. So it kind of runs the gamut when it comes to performance characteristics of generated code. It can be ported in quite a variety of platforms, from WebAssembly to the Sony PlayStation on a game or two, to PowerPC and many others. And it is actively developed by Microsoft and kept to the latest .NET version. And that is a project that we took a lot of use out of. It is, in essence, the other half of our platform. If we want to talk about just two components, it's NuttX and Mono. And here we go. Mono and NuttX, in general, was an easy thing to put together. It only took a year or two or three to sort of work properly. Mono had to be tweaked for having a small binary in order to fit. We didn't even manage to fit in internal flash for the STM32, so we wrote some code to break it apart and have it to external flash. So it's about 2 megabytes, but we managed to get the RAM footprint pretty low for .NET. We found small differences in how NuttX implements POSIX versus the most popular POSIX-ish operating system that Mono supports, that is Linux. But sort of once understood, it was just a matter of adding another if-def in Mono to support one more operating system, as it is used to having. We had to add support for nested POSIX signals, as signals are used by the garbage collector in Mono to stop threads and create a stop the world garbage collection environment. And we had to add that. I'm not sure if this is upstream, but please let me know after the presentation if there's any interest in that code or what you think about that. We had to use a cooperative GC thread suspend. We basically have to make sure we don't suspend a thread while it is in malloc, because in other systems, Mono uses kind of cheats and use malloc and mmap as two ways to do allocation that are not gonna deadlock if you accidentally suspend one or grab a lock that one needs. So basically, we had to make sure our threads tell each other when they stop at checkpoints and wait until all threads have stopped, and then a GC occurs, instead of POSIX signals being sent to threads in order to suspend them. It is a more robust thread suspend way anyway, if slightly slower. We switched to round robin scheduler for .NET threads. .NET system is the .NET system is non-deterministic in thread scheduling behavior. Or rather, I should say, it does not expect its threads to be in a real-time system where priority actually sort of matters more than softly. So in .NET, things can be initialized by any thread. So a high-level thread could be waiting for a low-level thread to initialize a type. And in .NET, in .desktop, that was always going to work. Here on FIFO, proper real-time scheduling, we're not going to see that. We're just going to deadlock as a lot of the times we had like tight loops and for initializing components in Mono. Finally, the app is loaded. Once Mono is loaded in the OS, the app is loaded from the Flash file system. It's just a DLL. If you don't know, .NET files compile into DLLs. And here's a big difference from other NuttX systems. Oftentimes, Mono plus HCOM for developer stuff is the entire user space. So from now on, the user is just accessing all of the system through the app.dll. So all of this just to get to console.writeline hello world. Not very impressive, but you're starting to get the picture that we're gonna be writing code within C# and .NET as much as possible. Another addition that we did here is this is all Neil Ferguson. Some of you may know him. He's a star. He's a little bit of a legend in porting Mono to different platforms. But Mono had support for ARM and ARM CodeGen, but not Thumb2 only CodeGen. It had some Thumb2 support. And now we have full Thumb2 support thanks to Neil Ferguson. The just-in-time native code generator in Mono works really fast and generates okay native code, which is in JIT compilers. This is sort of a pretty okay compromise. You don't want a slow compiler in something that is on device. That's just gonna take a while to just get an app started. And that gives us an increase over interpreter speeds as we are basically native code, if not that optimized. Mono plus embed TLS, that's some more work we had to do. Embed TLS is pretty standard for NuttX. We understand now even more as it is part of the repo, but it wasn't so for Mono. It was never really made for embedded. So we made embed TLS provider and added a root PEM store, and with this together, you can execute code that very seamlessly uses TLS. That's how .NET does it. You just put HTTPS in your HTTP client URL that you want to reach, and it's just gonna work as it would with HTTP. And then we have Mono as NuttX user space through Meadow Core. We expose as much of NuttX low-level feature functionality as possible through system calls and IOCTL operations. We're migrating to just system calls, but just historically right now we still have IOCTLs. So we are creating bindings in .NET because .NET interoperates with C code very easily and efficiently for doing all kinds of serial protocol communication, power management, connecting and disconnecting Wi-Fi, receiving Wi-Fi events, scanning for networks. We are bringing all of this into C#. So, that's the wrong thing here, but we provide this as a way for people to access low-level features while going through a safe wrapper, safe through the .NET language of type safety, memory safety, and bounds checking that it uses, but also using wrapper code in order to make this as a delightful experience as possible and make sure things are not accidentally abused. But basically, we have direct programmatic access of the STM32, and through that we have a whole peripheral ecosystem of over 300 devices, from geolocation to displays to cameras to sensors. Tons of utility code for working with these displays and sensors, and all of this along with Meadow Core is open source, and very easy to add to your platform, very easy to modify similar drivers to adjust it to similar devices. and heavily tested. So all of this is already part of the platform. And finally, we have work that Neil Ferguson again did in NuttX and has recently been merged. This unblocked us from using DLOpen and DLSim on the STM32, which allows code like the code over here below of just loading a dynamic library linked against linked against Meadow OS and its libc, and then just calling it. So we have used it to get TensorFlow on Meadow OS, and I'm working to get libjpeg and other standard libraries. And as soon as we build them, using them from Mono is direct. In fact, many of these libraries already have .NET bindings. So oftentimes it's just a matter of getting a build, and then people can use just base C# without writing anything more. Future of Meadow OS, there's a lot that we are excited about to do that are working on the OS itself. But from the NuttX perspective, we are very excited to get to the latest NuttX. We are way behind because we are still on NuttX since we started building Meadow OS back in 2019, I believe. And that was before I joined the team. The effort is underway and we got it to boot. And we need to put Mono on it and see if that runs, is where we are. There were many small challenges with basically with reporting some things. A lot of our custom kernel code, especially for the ESP, had to be tweaked as internal structures for networking have changed considerably. But in general, we are excited about CAN bus support in latest NuttX. I'm not sure exactly when it was added, but it was not in 7. I2S for audio, which Alan has recently helped get on the latest Meadow OS, but not we couldn't get it back to 7.3. And similarly to that upgrade, we need to upgrade our other major component, Mono. It is also kind of in 2019. Again, very robust, and the .NET Standard 2.1 is a long-term target for .NET libraries. So there's a lot of surface here, but we want to be future-proof, and recent.NET is even faster, more memory efficient than what we're using. So we are, of course, excited to get to that. And really, as a pipe dream, as maybe even a personal pipe dream, realtime.NET is something that we would love to bring to the .NET world. It would mean a lot of changes in both how we think about .NET, as it's never been a real-time system, but a subset of it can be. So the concept of a .NET or a .NET thread not using a heap and under other limitations can execute some code in real time in isolation. And that way we'll be able to actually provide that feature of NuttX to the .NET world. As I hope it was clear from before, we're not trying to be a platform for real-time apps, as .NET is not real-time. If we're going to do that, we have to change .NET itself. So big goal, have to convince a big company named Microsoft, but we like to be ambitious. Thank you so much to the Wilderness Labs team, everyone from the Meadow OS team to the founders, anyone in between. Thank you so much for making what we did possible, and for all of us, for all of the team for continuing to work on this. through many years to get to the point where we are today. Thanks to the Apache Foundation for this workshop, and the NuttX community for supporting MeadowOS in PRs, open source contributions, comments, etc. We'd love to know more of you. Many of you that we already know, we love. NuttX is a great project, and we are happy to be part of it, even as just users. Thank you. Thank you very much. Are there any questions? I guess I should ask here. If there's, I'm not sure if I have someone of an in-between who can tell me if we have questions on YouTube.
Thank you, Alexis. Actually, we have a question from Tomek. He is asking, you told the C#.NET is safe and secure, and he's asking how it compares to Rust, that claimed to be the most secured language of the world.
It's
at least I think you can defend the code quality, right? Because for a human to learn Rust is not that easy.
Yeah, this is a very good argument, and I am not gonna talk badly about Rust. Rust, however, is not currently a rapid application development language. It takes very long time to prototype things. It's also like a little bit behind on embedded. So if Rust gets better when you say APIs, etc., then yeah, that is a good language to use for Meadow. In fact, I tried to leave it vague in the beginning versus .NET because our CEO Brian Kostanich's vision for Meadow is that it doesn't have to be .NET. It can be any modern language that provides type safety and memory safety and bounds checking, etc. And Rust can be definitely more efficient than putting a runtime. However, in safety, they are about the same. Rust solves the issue in a very powerful way with the borrow checker, whereas .NET uses a garbage collector that sweeps in at different times. Rust's approach, when done right, is probably much better for real-time applications. .NET, however, has also moved away from using the heap for a lot of its work and can work with either spans on working with span times on stack, etc. So direction that .NET has been taking is zero allocation or low allocation applications, and that's where you get Rust similar to Rust's behavior. They are, but in the sense of the guarantees that they provide, they are similar. They are both are memory safe. Both do not allow you to improperly abuse memory, and both allow you to do it if you type a few magic keywords, because you sometimes have to. But yeah, Rust is definitely something that could be a Meadow platform target. However, yeah, .NET is our current one and the one that we're putting the most effort into. Thank you for the question.
Thank you. I think it's a good explanation. Some question from our local audience here. Question? Seems no question here. So, Alex, thank you very much for your time. I know it's not easy to wake up 5 a.m. just to be here with us. And thank you for your great work with NuttX and Meadow, and to be a good help and support to NuttX.
Thank you, everyone, in the NuttX community for your work. I would love to find a way to chat with you afterward, but also within an hour, yeah, I might crash. It is very late/early here, but thanks, everyone.
Thank you very much for the effort.
Yeah, it was really nice and really great presentation. And yeah, I think we can have more integration in our community, right? To also, for example, to have more NuttX things in the Meadow event, and also more .NET Meadow in our NuttX events. I think with this, we have the third presentation, because Mark presented in the past about the Wi-Fi ESP32 integration in Meadow, and also Neil present about the ELF dynamic loader that was implemented to Meadow and integrate on NuttX. And now
Yeah,
you're contributing overview what is Meadow. Yeah.
yeah. I gave more of an
It tells the
overview.
picture.
Yeah, yeah. It's you've seen parts of it before, and I think it would be very useful to link to those presentations for Neil and Mark's work. So if there's a chat for everyone
Yeah.
online, let's I'll send you the I'll send the links here and can put those on.
Yeah. And just a question, because I also have some, I don't know too much about .NET, but for example, you can just load the dynamic library and use the function, right? The native functions, correct?
Yeah, you just have to match the signature so that it's correct, and then you just call them. And
Mhm.
.NET auto generates marshalling code between C and .NET. So
Yeah, so it is similar to Java GNI, right? Java native interface
yeah,
to
I forget.
call C function or.
It's been a while since
Mhm.
I did GNI, but it's very going back to, I don't know if you can still see the slides, but uh, this little snippet is all you need basically, and then that function is implemented basically from the aspect of .NET. So there's now a function called tflight
Yeah,
microinterpreter invoke, and you don't need to do anything else. Just you need that attribute that says DLL import. So it gets the name of it finds the name of the symbol because it matches the name of the method. So there's a little bit of magic going on there. But .NET is really good at interoperating with C. It's very, very seamless. So um, allows this binding of native libraries for things that are too intensive to do in .NET, or standard libraries such as TensorFlow and libjpeg can just be loaded and used.
hmm nice. Uh, uh, a question about it is that the only way to load? Imagine I don't want to load external library. I just want to compile C code and integrate directly. There is some other alternative, or it needs to be a library and loaded that way.
Yeah, the Meadow, yeah, the OS platform is always C# and .NET centric. So if that, yeah, I guess that's the part where I meant this is a whole user space. If you want to run C code, it's going to be a component of your C# code. Always the C# code starts first, which is, yeah, counterintuitive, but
Right.
all of the startup code and a lot of the OS code is in Meadow Core and Meadow Foundation. And yeah, you just then call the C code.
Okay, perfect. Thank you very much again, Alex, and thank you for being here.
Thanks, everyone.
Thank you.
Nice to see you, and have a good day.